What is up, everybody? Today, I wanted to just make a quick video talking about privileged pods. And that's because privileged pods are one of the most common issues that get detected by scanners. And so I just wanted to spend a minute talking about what they are, why you might see them, and most importantly, how to fix them. So first of all, what is a privileged container? I will link this article down below. That's a great summary of some different container vulnerabilities, but this is a good image just describing that most containers, like we talked about, can only access the kernel insofar as they're running commands within their own space. But a privileged container is able to go down and interact with the underlying host itself. So this gives it access to all of the file systems and all of the processes of every other container that's running on that host. And so there's a couple reasons that this might have happened in a lot of different environments. I think the most common is that before there were really great ways in which to interact with Kubernetes, or it was really well understood more, there's always been good ways to interact with it. But a lot of developers getting started with Kubernetes approached the problem with a very old school way of thinking about Linux, where they were building their own nodes that they had SSH access into, and then they could interact with the container processes directly. The container might be interacting with the root file system on the host. And so it's a lot of ways of just thinking about containers as like processes running on hosts. And if you have that sort of understanding, you might have built an architecture, especially early on, that took advantage of privileged containers in order to access other things that were on that host file system. So a super common alert in most security tools is that a privileged container is running. And so I just have that up here in Armo. One of the cool things that they actually do is the smart remediation thing, because one of the hardest things about fixing this is that it is very scary to go in and turn this off. So all I have to do to fix this finding is delete this privilege equals true, and then I can go about my day as normal. What's hard is that if you have like especially a legacy workload, which are the hardest to fix, and it's interacting with the host file system or using it to do some funky stuff, maybe monitoring the underlying node, maybe writing files to the host and using that as an in-between to pass files around between containers. It can be really scary to delete and remove this access if you don't know that it's going to bring down production, which is obviously where you can't go. So this is one of the cool uses of eBPF as it continues to expand in capabilities, is using eBPF to detect, hey, is this container interacting at all with the underlying host OS? Because if not, it's a 2-second fix. I can go ahead and deploy it and move on. But if it is, then I have to do a more major change to the entire architecture. Okay, so now I want to go ahead and exec in and show you what an exploit of a privileged container might actually look like. Go ahead and get our pods, and then go ahead and exec into one. All right, so now that we are execed into a pod, we can check what disks we have available. And here you see the host disk itself, which is the underlying OS. So now I'm making a directory to mount it to, and now we have the file system for the underlying host attached to our pod. So now that I have the file system mounted here, there's basically no limit to what I can do. I can start editing different files on here. I can change passwords. I can add myself as a new user. Basically create a backdoor, upload malware, like any way that I can get into the root node. And then from there, I have total ability to get into any container that's running on the host. And so this is basically what it means to have a full exploit of the system. All right, so now that we know how dangerous this can be and that we want to try to solve it, let's talk about some of the issues that come along with like compliance scanning for some of this stuff. Is that usually like people look at this, and when you evaluate security tools, too many security teams just stop at like, oh, it's detecting that I'm using a privileged container. That's great. I'll just go fix that. But then the reality is that fixing it becomes very quickly more difficult than that, because the first fear that everyone has is, I don't know what this is doing. And then you pass it to the DevOps team and they go, I don't know what this is doing. And then it passes to the AppSec team and they realize that that guy's not there anymore because he quit 2 years ago and left this giant piece of tech debt for everyone. And so we don't really ever know if we can turn off privilege. So one of the cool things that Armo's done to try to like reduce that noise, and I think more and more people are going to add stuff like this going forward, is the fact that you'll see here that they have smart remediation and that 2 of the resources failed and 4, the risk was accepted. And so what that means in this context is that if the risk was accepted, then it means that the pod is actually using the privileged mode that it's running in because it's interacting in some way with the host operating system. And so this is a great way to sort of like tune out what's an easy fix, because ultimately at the end of the day, if I know for sure something is not using the privileged mode, then it's no problem for me to fix it, right? So for this deployment with the workload security evaluator, in this one, you can see it's very simple to turn off the privilege mode. I can delete it. The analysis indicates I can turn it off because the workload doesn't use it. It is a realistically, as a security person, I can do the unthinkable and just fix this myself by going in and deleting it. And I can have a high confidence that it's not using it. And then I tested here just to see how quickly it updates. And I was shocked that this actually updated pretty quickly to show that the privilege capability was actually used in this workload once I did the stuff to make it so it looked like it was using it. Instead, I have to accept the risk to say, hey, we're running this in privilege mode and it does use it. And then it becomes a question of like, so for the insecure app, I know this is using privilege and I need to actually think about what is this doing? Does it need to do it? And that's where you get into the messier, like, let's research this, let's fix it. But what I like about this approach is it basically turns this compliance finding list, which is normally like super useless because it's just this giant list of like hundreds of findings that no one's ever going to go and fix. This smart remediation flag actually tells you a lot about like, hey, you can just go in and get rid of this. Like, it's not being used. So like I also mount a host file path. Let's just take a look at that. And same thing here. I can see here's all the resources that it failed on. Here, I don't use it, so I can turn it off. Here, I don't use it, and I can turn it off. Like, this is a big problem with most is just to give an idea of where this is super useful, is these are all built-in AWS plugins for EKS, and so you can't really do anything about them anyways. But they do actually require mounting these various drives, right? And normally these create like a ton of issues and confusion for security teams where they say like, hey, you got to fix this. And then the DevOps guy's like, hey, are you an idiot? Like this is using the EBS CSI. Like I can't do anything to change it even if I wanted to. And Armo's tuning some of this stuff out just based on the fact that it is getting used. And so it requires some amount of additional information. So I think this is a smart way to enrich compliance type findings with runtime information. And I think that that's getting more and more to a lot of the people who have done compliance scanning are building more and more runtime features to inform the compliance scanning. And a lot of people who built the runtime features are building more and more code context to help bring in some of that. And so this is just a good example of a smart way to like tie those things together. So really all I wanted to show is that pulling the thread on these compliance type discovery things is very important to do. And there's different tools that are out there now to help us prioritize and figure out how to do them. And so privileged containers is a great place to start because like 99% of the tools I've seen have some detection for it. And it's usually the first thing that security teams sort of like dive into when they're fixing things. But I've seen confusion on two sides. The first is not really knowing why it's bad. And it's true that if something's running in privilege mode, it doesn't automatically make it like super exploitable. It's just a giant risk to, hey, if anyone gets access to this pod, you might as well give them access to your entire infrastructure because they're going to be able to sit there and transition between nodes, transition, like all of the defenses wear off. So it's a defense in depth mechanism. And then I wanted to highlight the way that Armo's dealing with like this cool ability to read runtime insights into that to help you figure out like, oh, I can fix like 60% of my privileged pods just by myself, and it's super simple. And maybe like 10% of those are hard findings that you need to think through. And ultimately, that's my big highlight is like when you're doing evaluations of security tools, to not just stop at the demo where it like shows you the scan results, but to actually try to fix things because that's where you'll realize where the difficulties really lie along the way.